Kia ora Year 12 and 13. This is a video about parabolas, which are the last of the conic sections that we look at. Now, I just want to apologise at the start that my stylus for writing with is at school, and I'm doing this one at home today. So I'm going to be doing this with my finger, but hopefully it will still work. So the basic form of a parabola is this: y squared equals 4ax. Now, it's a parabola that is a bit different from what we see in Year 11 and 12. It looks like this. This line here is the vertical line at x equals negative a, and we call that the directrix. Okay, so we can put on the other side, on the x-axis, the vertex of what's going to become our parabola. Sorry, not the vertex, the focus. The focus. Right? And now, what we're looking for is the locus of points such that the distance from this line, the dotted line, to the focus is equal. So we can see that one of those points must be at the origin. Okay, and we can trace out a parabola like this. Okay, now I did the proof of that in class. It's quite easy and it's done very nicely in Delta. But what we've got going on here is that any point on that parabola has the property that it's the same distance from the directrix to the point as it is from the point down to the focus. Right, so you can see this kind of pattern. So this is how parabolas work: here to here, and then from here to here, and then up to there. So every point that satisfies this condition will be on that red locus there. So that means that when we work with parabolas, they are quite different from working with hyperbolae or ellipses, because we don't have a B and we don't have a C for our focus. The focus is pretty easy to get with a parabola. It comes straight out of the equation if we know the equation. So this A term is basically going to be my focal length. Alright, so we'll look at some more examples on the next slide now. Right, sorry about the microwave beeping in the background. That's what that noise is. There we go. So here's my parabola. So we've got y squared equals 4ax. I'm keeping with the general form. So the vertex is at 0, 0. And the focal length is a units. So when I'm working with the basic form, that means my focus is here at point A, A0. Okay, and the directrix we don't see, but it's hiding in the background, so that's that line there. The last thing that helps us to sketch is called the latus rectum. And we get this by substituting the focus value into the equation. And that gives us this chord here, right? So if we do that, if we substitute in point A, we get y squared is equal to 4a times a. So we have y squared equals 4a squared, which gives us two values for y. Y is equal to plus or minus 2a. So the length of the latus rectum is always 4a, right, which matches up to what we've got in that equation. And that means I can plop 2 points onto my curve, one at 2a and one at negative 2a. But for that to work, I have to go from where the focus is. Okay, so if we know the focal length A, we know enough to draw the parabola and write the equation. Alright, so let's look at how transformations work for these graphs. Let's look at this one. Suppose we've got y squared equals x minus 2. Right, if we're working with parabolas at level 3, we want to write it into the form y squared equals 4a times x minus 2, because the focal length, or the focus, is very important. So we look at this x minus 2 as a whole, and we say, well, that is a horizontal shift to the right 2 units, as it is with all of the other graphing work we've done. So in here, we've got y squared equals 1 times x minus 2. So we've got 4a is equal to 1. So a is equal to 0.25. Right, so A is my focal length. All right, now it's not going to be exactly where my focus is because I've shifted this parabola over. So I'm working with x minus 2, so I'm translating my basic parabola form by the vector 2, 0. Okay, so we can draw that now. So let's draw some axes. Well, we know the vector has been transformed from 0, 0. Sorry, the vertex has been transformed from 0, 0 to 2, 0. So we can put that on here. Now we know the focal length. So the focal length here is at 2.25. Right? And it's easy to draw this one using the idea of the latus rectum, which means we're going to go up by 2a from this point here. And we're going to go down by 2a. So 2a is 0.5. So the point here and here, so we can draw this in. Sorry, there's no beautiful GeoGebra graphs today, but hopefully it gives you the idea of how we would sketch. So we get up here we're at 0.5, down here we're at negative 0.5. Now some of you are probably going, well, why would we bother to do that? Because we could have just substituted any old point, and that's right. So in this one, another good one to do would be to substitute in when x equals 3, y squared is equal to 1. So at 3 we go to 1 and negative 1 down here. Okay, I think I should start calling my YouTube channel Maths with Very Bad Graphs, but hopefully that gives you the idea, right? So key things in there, again, you're looking for, first of all, the horizontal transformation, if you've got it in this form, and you're going to put brackets around that. And then you're looking to say, well, what's my 4a term? I need to know that because a is crucial for these parabolas. It's the focal length, and it drives the shape of the graph. I didn't ask you to do this here, but the directrix in this case is going to be, again, the focal length back from the vertex. Okay, so the focus is at 2.25, the vertex is at 2, and so the directrix will be at x equals 1.75. Okay, right, I'm going to do a couple more on the next slide, and then we're going to look at how to write the equation once we're given a parabola. Okay, so a bit more practice. So y squared equals negative 8x. Well, this is a different pattern type. This is going to be a parabola that goes like that. There's my origin there. So it's reflected in the x-axis. So we'll write this in the form y squared equals 4ax. So a is equal to negative 2 here. What does that mean? Well, it's a bit funny to think of a focal length as being a negative number, so we'll think of the focal length as being the absolute value of a, which puts my focus back here at negative 2. Okay, so the focus is at negative 2 and 0. So far we've done them in this form, y squared equals 4ax and y squared equals negative 4ax. Now we're going to look at x squared equals 8y. So this one is going to go like this. Again, the pattern here is 4ay, so x squared equals 4ay. So a equals 2, my focal length is 2, and my focus is at 2, at 0, 2. Right, and the last pattern type is x squared equals negative 8y. So pattern here is x squared equals negative 4ax. Whoops, negative 4ay. A equals 2. So this one would look like this. Okay, same idea applies. Whoops. Right, now we're going to look at how we can go from looking at a graph to writing the equation. Okay, here comes the first one. Right, suppose we've got a vertex here at 5 and I tell you the focal length is 2. So what's the equation of that one? Well, it's going to be y squared equals 4a, and it's been shifted out horizontally 5 to the right, so it'll be this. So in this case we're going to have y squared equals 8x minus 5. Right, if the focal length is 2, the focus is at 7, 0. Right? So remember, we can think of this as being the original parabola transformed by a vector of 5, 0. So the original parabola has got a focus at 2, 0. And we want to transform that by this vector, so it goes out to 7, 0. I'm going to see if I can fit two graphs on one page. Let's try this one. Right, my vertex is at negative 3, 0, and I'm going to tell you that the focal length is 1. So let's write the equation for that one. Well, it's going to be in the pattern again. Y squared equals 4a. It's had a horizontal shift left by 3, 4ax plus 3. Now I'm told the focal length is 1, so that means a equals 1. Okay, so they're that easy. They're definitely easier once you get the hang of them, I think, than ellipses and hyperbolae. It's just a bit weird because you start off by going, well, how do I get my focus? Why isn't it c squared equals blah, blah, blah? But it's not. It's just given to you, usually. Okay, so here the equation will be y squared equals 4 times x plus 3. And if the focal length is 1, the focus is going to be here at negative 2, 0. Okay, so if you like thinking about translation vectors, the translation vector of the basic one is negative 3, 0. Okay, let's try one that's facing the other way. What's the equation of this? The vertex is at negative 6, 0, and I'll tell you the focal length is 2. So it's going to have the pattern. It's a backwards one, so it's going to be y squared equals negative 4a x plus 6, and a is 2. So the equation will be y squared equals negative 8 times x plus 6. And the focus is going to be 2 away from here, so it's going to be here at negative 8, 0. Okay, if you're just sitting there and watching these and thinking you're getting it, it's probably a good idea to go back over the video and pause when I introduce the graph and just check that you can write these equations. I am going to do, how many more? 3 more of the different kinds of shapes that we can get. Okay, so here's one. Actually, this time I'm going to draw them both up. So vertex is at 10, and I'll tell you the focal length is 1. And this one here, try this one. Vertex is at 3, and the focal length is 2. Okay, so pause and have a go. Remember, you've got a transformation and you've got a focal length to fit into your equation. Alright, so this one has the pattern y squared equals negative 4a times x minus 10. Right, negative 4, because it's facing in this direction, so it's a reversed one. Okay, and a is equal to 1, so the equation is y squared equals negative 4 times x minus 10, and the focus will be here at 9, 0. Right, on to this next one. Well, the form here is going to be x squared equals 4a, it's been translated up, y minus 3. Okay, the focal length is 2, so a equals 2. X squared equals 8 times y minus 3. And the focus will be 2 up from the vertex at 5. So carefully, focuses at 0 and 5. Alright, one more. Okay, last one, and you probably guessed it's going to be a downwards facing one, so there's my vertex is at -1, and I'll tell you the focal length is 0.5. So the pattern is x squared is equal to -4a. It's been shifted down one, so it's y plus 1. So a is equal to -0.5. The equation is x squared is equal to -2 times y plus 1. Now I've done a mistake in there. Hopefully you saw it. That a, the focal length is 0.5, not -0.5. So just make sure you check your equation back that it makes sense. Right, so it's an x squared one, and it's a negative because it's downwards oriented. So where's the focus there? Well, the focal length is 0.5, so it's going to be 0.5 down here at -1.5. Alright, that's plenty on parabola to start us off. Thank you for watching. I'll try and do some more applications ones later on today.